Hi, I'm Katrina Cunningham. I'm a research fellow in the Aberdeen Spinal Injury Research Team. In this short video, I'm going to tell you a bit about the project I've been working on since I joined the lab in November 2019. It's been made possible by funding from the Scottish Rugby Union and Graham and Pam Dixon, so thank you very much to them for their ongoing support. Your spinal cord is a nerve motorway that connects your brain with the rest of your body. When the spinal cord is injured, signals travelling down from your brain telling your legs to move, and signals travelling up from your skin telling your brain what you can feel, are disrupted, leading to loss of movement and sensation. The Edwin Smith Surgical Papyrus described spinal cord injury as an ailment not to be treated, and today, nearly 4,000 years later, there's still no cure. So why haven't scientists found a solution to spinal cord repair yet? It's because regrowing nerve cells face a number of roadblocks on their journey to reconnecting the motorway. Firstly, there's a physical barrier caused by scarring and the formation of a fluid-filled cavity. Secondly, the environment of the injured spinal cord is very hostile. A number of molecules act like stop signs and prevent nerve cells from regrowing, one of which is a fatty substance called myelin. In the healthy spinal cord, myelin insulates nerve cells and allows signals to travel faster, but after spinal cord injury, damaged myelin isn't cleared up efficiently by immune cells. They're like dysfunctional road workers not removing debris after an accident. A further problem is that adult nerve cells have a very poor inbuilt capacity for regeneration, compared with the nerve cells of babies still developing in the womb. It's like taking a horse and carriage on the motorway, instead of your Aston Martin. For the past several decades, most research has focused on single target therapies for spinal cord repair, such as testing a single drug or growth factor, and the success of these has been really limited. Our hypothesis is that to overcome the roadblocks, we instead need to find the right combination of therapies, and that's the focus of my project. The first part of my novel combination therapy is the stem cell secretome, a collective term for the vast cocktail of proteins and growth factors the cells make and release. There's growing evidence that it's this secretome that improves recovery in rats and mice after spinal cord injury, rather than by the transplanted stem cells surviving long term and turning into nerve cells to replace those lost after injury. We hypothesize that the stem cell secretome will provide biochemical support to regrowing nerve cells and allow them to ignore those stop signs. The second part of my combination therapy is an injectable hydrogel, 3D networks of polymer chains that hold a high water content. I prefer to think of them as fancy jelly. We expect that the hydrogel will provide structural support to regrowing nerve cells, like resurfacing works on a motorway. We hypothesize that the hydrogel will also act as a slow-release drug delivery system for the secretome, allowing the secretome to work for longer and guide the traffic of regrowing nerve cells more precisely. We hope our research will find a novel combination therapy able to overcome the roadblocks to spinal cord repair and restore function to patients. Thank you very much for watching. If you're interested in learning more about our work, I've included links to our lab's website, Twitter and Facebook in the description below.